Hi, in this video we're going to be proving triangles congruent using either side, 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 angle, or angle, angle, side. So in these problems, the triangles are definitely going to be congruent every time. We want to mark any additional pairs of parts that are congruent and write a congruence statement for each pair. We need to write a reason for our pairs, make our triangle congruence statement for each pair, and circle the postular theorem that justifies that congruence. So some of these are started out for us. So here, this is already given. We know that W and Z are congruent because that's just like marked on our diagram. These two are congruent to each other. We also know that these angles up top are also congruent. So these ones up here, they're congruent to each other. We just need one more pair of parts. Well, hey, I know this thing right in the middle is going to be congruent to itself. So that'll be a nice angle, angle, side. I might as well just mark that right now because I've got a pair of angles, and a side, pair of angles, and a side. So this is angle, angle, side. But I need to write what's going on here with Vy. So I know Vy is congruent to Vy. Because that is a reflection of the two. Now I just need to write my triangle congruence statement. I want to go 1, 2, and unmarked. So 1, 2, and unmarked. So that ZVY has got to be congruent to WVY. There we go. So in this example, I know that IE and GH are congruent. And I know that EF and HF are congruent. And so that's getting me a pair of sides and a pair of sides. I need one more thing that is congruent. Now you want to be careful of bad rabbit holes. I can say that this angle here, that these two are congruent using vertical angles. But that's not going to help me because then I end up with side-side angle. Side-side angle is not one of the things that we're able to use as our congruence statement. So while we do know that these two are going to be congruent to each other, it doesn't help us get to one of these statements. What we can say, however, is based on this, since F is the midpoint of GI, that must mean that this and this have to be congruent. That's what midpoint does, is it breaks the segment into two separate parts. So I can say IF is congruent to FG. And I can do that thanks to the definition of midpoint. Now that I've got that, I've got a nice set of side, 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 side. So I'll use side, side, side. Side, 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 if I can say it again, is going to make these two triangles congruent. So IEF. I went across my first and my second. So over here, I want to do the same thing. First and second. So GHF. Now this next example, I didn't get quite as many givens, but I did get one given. So I know that QR, so this side up here is congruent to this side down here. And I need some more bits. So I do know that QT has got to be congruent to itself. So I know this has got to be congruent. And I could also say, thanks to alternate interior angles, I could say that these angles have to be congruent. If you've got a set of parallel lines and you cut them with a transversal, then you get congruent angles here and here. So Q and T are alternate interior angles from each other. Great, so I just got to fill that in. I'm going to start with this side. So now I've got to fill that in. I'm going to start with this side. QT has got to be congruent to QT. And I could do that thanks to the reflexive property. And then I need this angle down here. It's kind of a confusing angle, so I'm going to need 3. So RQT. RQT has got to be congruent to STQ. So that makes this triangle and this triangle congruent, and I'm using a pair of sides, a pair of angles, and the pair of sides. So it was side, angle, side, doing the same thing over here, side, angle, side. So we're using side, angle, side to prove our triangles as congruent. I just need to make my triangle congruent statement. So I went side, this angle, and then that side. So it was triangle STQ. That's got to be congruent to our side, our angle, and our side. So RQT. All right. Nope, I almost forgot. You're probably screaming at the screen. I didn't write why this was true. This was true because of alternate interior angles. Sorry for not writing that. There. Now I've got all my reasons and then my triangle congruent statement. Oh no, in this example, we didn't get any givens right away for our pairs of parts, but the given information that we got up here should help us get to our actual pairs of parts. So if I'm looking at this diagram, one thing I can mark right away without even thinking all that much is I know that these two have to be congruent to each other because those are vertical angles. The other thing that's kind of marked and kind of clear is that these are congruent. These are both right angles. And if they're both right angles, they've got to be congruent. We got that from this perpendicular thing, that these are perpendicular and these are perpendicular. But that perpendicular gave us right angles, and right angles are all congruent. So that's two angles. If we could get a side in between them or a side on one end, we'd be able to use one of these two. And that's where this is coming in. T is the midpoint of PR. Since T is the midpoint of PR, that tells us that these two sides have to be congruent. Oh, cool. That's angle, angle, side. So now we just need to list those parts out in our pairs of parts. So I've got this angle right here. So that's QTP. That's got to be congruent to this angle over here, RTS. Angle real-time strategy. And we were able to say that these two are congruent because they are vertical angles. Then we were able to say that angle Q and angle S are congruent to each other because they're right angles. So angle Q is congruent to angle S because all right angles are congruent. I'm going to abbreviate it. All right angles are congruent. Great. And then our last bit was that these segments were congruent to each other. We got them from that definition of midpoint. That's what a midpoint does, makes PT congruent to TR. So the last thing we need to do is just write a triangle congruence statement. A triangle congruence statement Let's see. We'll go QTP because then we got angle, angle, and our side that matched up. So QTP, angle, angle, side that matched up. So STR. There we go. All right, in this next example, again, we don't have any givens right away, but we do know things bisect each other. Just looking at this diagram, I know that the vertical angles, those are congruent, so I'm just going to mark that. So I got it. What else? If they're bisecting each other, if AE is bisecting this line, that means if it's bisecting BD, that these two segments have to be congruent to each other. And also BD bisects AE. Since they bisect each other, they cut each other in half. So that must mean this also gets cut in half. So we get that vertical angle in the middle. We get those pairs of congruent sides. Hey, that's side, angle, side, side, angle, side. So this one's side, angle, side. Now we just need to list out that information that we found in the diagram. So I got to talk about this angle C. Let's go ACB. That's got to be congruent to DCE. That's our good friend vertical angles. The next one we got was CD and CB were congruent to each other. And the place that we got that was the definition of bisector. Kind of like up before, we did that definition of midpoint, definition of bisector works the same way. And it was using that same logic that we're able to get that other pair saying that AC is congruent to CE. That's that same definition of bisector. So with all of that, we've got all three of our bits marked as congruent. We're doing side, angle, side. It's just time for our triangle congruent statement. So let's see. I'm going to go across one, our angle and our side. So CDE is going to be across that same side. I did the one tick. I better do the one tick again. BCA. All done. That is it for this video on proofs. I would recommend to make sure that you can get your proofs to mark up your diagram. As you kind of like mark things up in here, you can kind of see which theorem you're using, and then it's a lot easier to fill things in afterwards rather than just trying to write stuff over here on the side. Thanks for watching. Bye-bye.